Hello guys and welcome back. I just hope you have gone and completed the task that I left you with before tuning into this video. Okay, now if you have done everything correctly, you can just double check here. For term 2, you should have had 4a plus 2n plus c. For term 3, you should have had 9a plus 3n plus c. And for term 4, you should have 16a plus 4n plus c. I'll end at term 5 because of space, 25a plus 5n plus c. Now, what we are going to do next is to find the first difference, okay? Um, Maybe I should have said 5 terms instead of 6 because of my space here, but if you done 6, very good, well done. Now, I'm going to find T2 minus T1. So if you look at this, there are already what like terms, okay? This here should be 2b. I'm not sure where I get the n because I have substituted the n. And if you say no, you are wrong, I agree with you, I was wrong because I was supposed to have b's instead of n's, okay? Yes, so as I said, maths proves one irrevocable fact. We are all humans. We all make mistakes. So, yes, but be careful not to make such mistakes in the exam, okay? And that's why you've got to practice. Now, 4a minus 3 minus a is 3a, 2b minus b is b, and c minus c is 0. So if you are lost, let me just show arrows. What I'm doing here, instead of writing this whole thing down, I'm just going to say 4a minus that, because I can see there are like terms, and 2b minus that, and then c takes out c. Okay, and it's obvious in that throughout here we see it will always take out c, so we will be left in most cases with a and b. All right, so let's go ahead. Here you must be having 5a, because 9 minus 4 is 5, plus ab, and c is out as expected. And then again 16 minus 9, that's the next step. I hope you are still with me. And this obviously will give us a 7a, and then 4b minus 3b is just a b. C's take care of each other, and then again we come to 25 minus 16. This is a 9a, and you will see already with the b's, there's some pattern here that you will always be left with a b, not any, not 2b, 3b, anything. So let's look at the last one. We are now, because we know there's a quadratic sequence, we are actually expecting a constant difference now. Okay, so let me indicate here. I've written here that this is the general term. Now here, this is the first difference. I'm going to write first D, and here now we are dealing with the second D, the second difference of the sequence. Now, you can see in this case now, the B's are going to take care of each other. So I'm left here with a 2a, because that's what 5 minus 3a is. Here I'm also left with 2a, because that's what 7a minus 5a is. And 9a minus 7a is also 2a. So as expected, I actually have a constant difference of 2a. Now, I want us to compare this with the sequence that we already have, the specific sequence, which is this one here, Tn equals to 2n squared minus 6n plus 1. Okay, and I'm going to write this just on top of this sequence, but in red, okay, so that we can be with one another and not lose one another here. So I'm going to go ahead here and maybe use a different color, purple, maybe maroon, I don't know, but a different color, you will see it's different. For the specific sequence, T1 is a negative 3, and the next term is also a negative 3, that is the second term. The third term is a 1, okay, and the fourth term is a 9. Of course, guys, you've got space in your books, so do this very nicely as you can. And we can see the first difference for the specific sequence. Here it is a 0. Okay, we have done this already, guys. It can't be much of a debate. And here we've got a 4. We had a 4 here. And here, 9 minus what? Yeah, 9 minus 1 is an 8. And then lastly, a 21 minus 9 was a 12. That's what we've got previously. Now, we got that the constant difference here, this is a 4, this is also a 4, and this is also a 4. Now, think with me a little bit here. Since this is a quadratic sequence, we can actually do some comparison here and links. We can see that term 1, in other words, this negative 3, is actually equivalent to a plus b plus c. We can also see that 3a plus b is actually equivalent to the first difference between the first two terms of the quadratic sequence. And finally, we can also see that the second difference, which is 4 in this case, is actually equivalent to 2a. What I'm going to do actually in the next video, we are going to prove the general term for a random quadratic sequence. So go ahead and play around here and see if you can find any quadratic sequence. As a matter of fact, I can quickly put that one for you and try and test yourself and see if you can find the general term for that sequence using these relationships that I just established now. This relationship here, and I just wanted to take this one here, that one there, and that one there. Okay, equate the second difference to 2a, then solve for a. Equate the second difference to 3a plus b, then solve for b, because you then substitute a there, and then finally substitute a and b to find c. Okay, try that in the sequence that I am about to give you. So guys, go ahead and find the general term for this sequence here, minus 2, or rather negative 2, negative 2, 0, 4, and 10. Negative 2, negative 2, 0, 4, 10, etc. Go ahead, find the general term, and we will use this notation Tn to represent general term. Okay, so when we say general term, we're basically saying Tn. So go ahead, try find this using the conclusions from the discussion that we just had. Cheers.